In this particular video, we are going to solve the Leetcode problem of the day, and the problem is maximum number of points from grid queries. In this particular problem, we are given a grid which is a two-dimensional data, and this data is having numbers or integers. We also have a one-dimensional data queries, and this queries data is having some set of numbers, and for each query, we need to give an output. Now let me explain you the process to get the output for each query using the drawing pad. So our approach will be, we are first going to understand the problem, and then we are going to understand the intuition behind the approach of this particular problem, and then we are going to solve the particular problem in Python. Let us first try to understand for each query like 5, 6 and 2 which is given in our example, how the output is 5, 8 and 1. So we are given a grid, right? And the grid is having the dimension of R into C. R is the number of rows, which is 3 in this case, and columns is the number of columns, which is also 3 in the case. Now, the next thing is, let us understand for 5, how can we get the answer? So for each query, whether it is 5, 6 or 2, we need to start from the top left, 1, 1 and 1, or whatever number it is there in the top left, we will start from that number. And then what we need to do is, we need to check if this number is less than our query. And since the top left corner is less than our query 5, we are going to give 1 point to query 5. Then in that case, the point 1 is going to give 1 point to our query 5. Let us say 5 is our query and it got plus 1 point. And who gave the point? This particular data gave the point. Now after we got a point from a cell, we can go in all the 4 directions from the cell. So right now we are at this particular cell. Now we can move down, right, up and left. Now, since we know that we cannot move up and left because that is out of the scope of our grid, but we can go down from our point and we can move right from our point because at right we have 2 and at bottom we have 2. So we can check for the same condition for both of these points, that are the values at these points 2 and 2 less than the query, that is our query value 5 should be more than this value, and if it is more, then again these points are going to give 1 point to 5. 5 will have 2 more points. Again, we will have to do the same thing. Since we got a point from 2, we can again move right, top, left and bottom. Now the next rule to understand is, although we can go to left, but this cell is not going to give us another point because we already have a point plus 1 due to this cell. Although we could travel back to the cell, we cannot have another point from this particular cell, right? If you are visiting it for the first time, we will add a point. But if you are visiting it again, then we are not going to get the point. But we can visit to the point. But for this particular problem, there's no point of visiting back. So from this particular cell, we are not going left. We cannot go top as well or up as well because that's out of our grid. We can go right and we can go down, but we cannot go down as well. The reason is the value of cell is 5. Our query is 5 and 5 is more than 5. No, it is not. And since it is not more than 5, and that's the first rule we need to check, our cell value needs to be more than the query value. And if it is more than the query value, we are going to give it a point, and also we are going to move further directions from that particular cell. So we are not going to this point, but we can go to this particular point 3, because from 2 we could move right as well, right? So in that case 3 is going to give us another point plus 1. From this 3 we cannot go to any direction. We cannot go right because this is out of the grid. Again, top is out of the grid. Left, we already have visited 2, so no need to go back. And down, do you want to go down? Well, we cannot go down because the value of the cell is 7 and our query is 5. 5 is more than 7, that's not true. We are not going to go down. So we have saw these points. We also got a point from this particular cell, but we need to move further from this particular cell. So we can go right, we can go up, we can go left and we can go down. The left point is out of the grid. The up point or the top point is already visited. The right point is 5 and the value of this particular cell is 5 and our query is 5. So again 5 more than 5 is not true. So we are going to ignore this cell as well. But we can go down because the value of the cell at down is 3 and our query is 5. 5 more than 3? Yes, it is. So in that case, this particular cell is also going to give us one more point plus 1. And now again from this cell, the new cell which we got, P, we can go right, top, left, bottom. We are not going to go at the top, that's already visited. Left is out of the grid, bottom is out of the grid, and the right value is 5. It's again, the condition is not true. 5 more than 5, that's not true. So now at this point, we do not have any further cell to process. But you will have to notice one very important point here is, we do have a cell 1 which is less than our query, but we cannot reach to this point. The reason is we cannot go out of this particular border. when the query is 5. So if we are not going to go out of this border, and we know that we can only go up, right, bottom and left, and that too only one step, and that is why the output for the query 5 is going to be 5, because we have got 5 cells which is going to give us points 1, 2, 4 and 5, right? So for 5 we know that the output is going to be 5. Now let us start processing the next query, which is 6. We will have to start our processing again from the top left corner of the cell, which is this cell, the cell number 1, right? Now, before we start processing, you will have to notice a very important fact, a very important concept when solving this particular question or problem, and that is we have already processed the query 5, and for that we have got this answer, right? And now we are trying to process a query which is more than 5, right? We have 6 now. So for 6, these are the cells which are definitely going to be the answer, because we just have one rule, that start from the top left corner and go right, top, left and bottom, and go till the point for which all the cells value are less than your query value. So if these are the cells which are less than 5, then definitely these are the cells which will be less than 6, right? So for 6, we will already have total of 5 points, because for 5 we had 5 points. So again for 6, we will have at least 5 points which are less than 6 and connected from the cell top left. So these are already our answer for 6. But these are minimum. We can go further, because when we are checking for 6 and when we were on this particular point, then in that case we can go down from this particular cell, and we can also include 5 in our answer. So this cell is also going to give us one more point for 6. And again you will notice another fact, that if we are at this particular cell which has given us 1 point, so from this particular cell 5 we can also go down, right, top and left. Top we already have visited, left is already visited, we can go down, and when we go down we will find another cell which is 5, and this 5 will also give us another point. And now from 5 we can go right, but the cell value 7 is more than our query value, which is 6, right? So we will not go right, but since we have already visited this cell 5, we can go right from this cell, and the value of this particular cell is 1, which is less than our query. So this particular cell is also going to give us another point plus 1. And now you will notice you cannot go any further from any cell. So for this particular query 6, the answer is going to be 5 plus 1 plus 1 plus 1, which is 8. And you can see the output is 8 for query number 6. And now we need to process the input 2, or the query 2. For query 2, we are again going to start from the top left corner. This particular cell 1 is going to give us 1 point for query number 2. For query 2, let's add 1 point. Now you cannot go to any direction. You cannot go down, right, top and left. Top and left are out of the grid. We are not going to go there. And the right cell and the bottom cell has the value 2 and 2. And our query is 2. And since 2 is not more than 2, right, so we are not going to go any further. And in case of query number 2, the output is just 1, because we have just got 1 point. Now that's the way we are going to create the output. Now while processing these queries, we have observed one very important fact, that when we processed for 6, we already had an answer 5, because we already had processed a query which is less than 6. So from this we draw an intuition that if we try to process our queries in a sorted order, then for each subsequent queries we will already have some pre-computed answers. So what I'm trying to say is our queries are 5, 6 and 2, and we are processing it 5, 6 then 2. And instead of doing this, if we sort our queries, what our queries are going to be, it will look like 2, 5, 6. And now if you try to do the same operation, you will find that your code or your process is going to be optimized. Now, how are we going to compute the answer? The thing is, we will not be processing any cell again, right? We should have some kind of data which is holding what are the cells we have already visited, and we will create a set for it and we will call it visited. And this is going to store all the cells which are already visited by us. And apart from this, we are going to create a heap. So let us create a heap, and this will be a min heap. And initially, since we need to start from the top left corner, we will start from the top left corner and we will push this data to heap. So let us push this particular data to heap. The data will be 1, and which cell is this particular data part of? The cell number 0 comma 0. This is the row number and this is the column number. Basically these are the indexes of your cell. Now let us start processing our query one by one. So we will start with 2, and what is the first data we will get from our heap? That this data, the value of this data is 1, and we know that 1 is less than 2, 2 is our query. So this particular cell is going to be the part of our answer, right? And once we know that this is going to be the part of our answer, we will say the cell 0 comma 0 is visited, and this will be removed from our heap. Okay? But the moment you remove it, We are also going to add the neighbors of this particular data which we just processed, right? The neighbors are this and this cell. We are not going to go up and left because that is out of the grid, but these two cells are going to be added in our heap. We are going to add this particular cell and this cell in our heap. So it will be 2 comma 0 comma 1 and 2 comma 1 comma 0. This 0 1 and 1 0 are the indexes of 2 and 2. Next, the same process is going to continue. Now what's the next element in our heap which is minimum? So it is this particular data 2 comma 0 comma 1, but the value in this particular cell is more than our query. So we know that we just have one particular data which we have processed, and that's the answer for 2. So the answer for 2 is going to be 1. So let us start for the 5 and check the same thing. Is the next element is less than this particular data? Yes, it is, right? The query is 5, the next data is 2, and we know that this data is less than our query. So this will also be the part of our answer, and we will remove it from this particular heap. And we are going to say the cell number 0 comma 1 is visited now, and this is the part of our answer. And also we need to add the neighbors of this particular cell. So what are the neighbors? The neighbors are 3 and 5, right? We don't need to add this and this because this is visited and this is out of the grid. So the new data in our heap is going to be 3 comma 0 comma 1. All right, and also 5 comma 1 comma 1. This 5 is also we need to add because that is the neighbor of 2. Once we have added this data, now we need to process the next minimum element in our heap, 210, right? So let us start processing the data. In this case, you will find that the value is less than 5, and since it is less than 5, yes, it will be part of our answer. Remove it from the heap, add it in your visited cell so that we don't need to add this again in our answer. And once we have added this particular data, we know that we have to add the neighbors as well, right? What are the neighbors of this particular cell? So it is 5 and 3, right? We don't need to go up, we don't need to go left. Up is already visited and left is out of the grid. Okay, let's add those data. So the data is going to be, and we need to add this 5 as well. And we know that this is already added, but don't worry, we will add it, and you will see that we are not going to process it two times. So in this case, add 5 comma 1 comma 1 again. What is the next minimum element? It is 3 comma 0 comma 1, which is this particular element. And we know that 3 is less than 5, so we will add this in our answer. 3 is going to be the part of our answer. 3 will be removed from the heap. And let me correct myself here. This is not 1, this is going to be 2, because the cell number for 3 is 0 comma 2. That was a typo. So right now we know that the cell number 0 comma 2 is also visited, and we have processed 4 cells. The moment we are processing this particular cell, the neighbor is going to be added. We will add it. Don't worry about that the value of this is more than the query, because there might be a chance that there can be another query, for example 8, and for 8 7 will be an answer, right? So let us add it in our heap. We are not going to process it until and unless we get a particular query which is more than this particular cell. So let's add it. Now the heap data is going to be 7 comma 1 comma 2, right? But we don't need to process this data for now. We need to process this particular data because that's the minimum value we have, and we know that the value of 3 is less than the current query. So this is going to be the part of our answer. Remove it from here, add 2 comma 0 as visited, and mark it as answer. So for 5 we already had this particular data as an answer, and we got 4 more data as our answer. Now let us try to process the next minimum element. What is the next minimum element? The next minimum element in our heap is 5 comma 1 comma 1. Okay, let us try to process it. But when we started processing it, we found that the value 5 is not less than the query. So we will break from here for 5, and for 5 the answer is going to be 5. So the total number of cells we found as of now is 1, 2, 3, 4 and 5. All right, let's go for 6 now. So instead of 5, let's make it 6. Now what is the next minimum element? It is 511, and the value 5 is less than the current query 6. So we know that this particular 5, which is at index number 1 comma 1, that will be the part of our answer. So yes, 5 is the part of our answer, and it will be added in the visited cell. It will be removed from here now, and let us try to process the next particular data, which is 511. And before we are trying to process it, we will also add this particular 5 in our heap. And the reason is this is the neighbor of this 5 which we just got in our answer. So let me remove these data just to create some space, and now add the next data in our heap, which is 5 is the value. The indexes are 2 comma 1. So now what is the next minimum element in our heap? It is this 511, right? Now this 5 is less than 6. We know that this will be the part of our answer, but you will notice that we have already processed this data 1 comma 1. It is in our visited data. So do not need to process it, just cut it out and try to process the next data, which is 521. And now when you try to process this 521, this is your data. The value is less than our query. So it will be the part of our answer. So yes, this is going to be the part of our answer. And its neighbor, which is 1, is going to be added in our heap. So let's add the data 1, 2, 2. And the moment we add it in our answer, we are going to add 2, 1 in our visited set and remove it from our heap and check for the next data, which is 1, 2, 2. Yes, 1 is less than the query. So this will be the part of our answer. Remove it from here. And 2, 2 is going to be the part of our visited data. And the moment we found the next data in our heap, which is 712, we are not going to process this because 7 is more than the query. So in this case, we stop here for 6. And the total number of cells we got in case of 6 is, we already had 5. We got 6, 7, and 8. So the answer for 6 is going to be 8. And now, since we do not have any more queries left, this is the answer we have. But before we return the answer as 1, 5, 8, we are going to return it in the same order in which the queries were. So since the first query is 5, 5 will be our first answer. Second query is 6, 8 is going to be our second answer. And 2 is our next query. So 1 is going to be our next answer, but particular 1. 5, 8, and 1, we got the answer. And this will be a very optimized solution for this particular problem. And now, since we know how can we solve this particular problem, let us go back to our code editor and start solving this particular problem. First of all, we need to store the number of rows and number of columns. So rows will be equal to the length of our grid, and the number of columns is going to be the length of any particular data in our grid. So length of grid of 0. Now we need to create a visited set that will be equal to visited equal to set. And we also need to create a min heap, right? This is the heap we are going to use in our solution. And we are going to initialize this heap with the first data. So the first data is grid of 0 and 0, and the index is 0, 0. So this is the value and these are the indexes for it. And since we have added this in our min heap, we need to add it in visited as well, that visited 0, 0. Now heapify your data. This heapify function, this heapify method will make your min heap as a heap data structure. So min heapify. So min heap will be heapified, and let us create our result. Result is going to be empty dictionary for now, and we are going to store our current answer. So current is equal to 0. Now start processing our query for query in queries. And now we know that we need to use the sorted data. So sort our query, sorted queries. Next is we need to run another loop while we have some data in our min heap, and the current query is more than the min heap. Store the three datas, value and the indexes. This will be equal to heap pop. And then we are going to store the neighbors of this particular data which we have just got. So I comma j is the index we have got. What are the neighbors for this? The neighbors are going to be I plus 1 comma j, that will be right. Then I minus 1 comma j, this will be left. Then I comma j plus 1, this is going to be bottom. And I comma j minus 1, this is going to be top. So our current value is going to increase. Current is plus equal to 1. Then run a loop in our neighbors. So for I comma j in neighbors, we are going to check first few conditions, that if I is less than 0 or j is less than 0 or I is equal to rows or j is equal to columns. These conditions are going to make sure that the current I and j is not out of the grid. And there is one more condition, or the combination of I comma j in visited. Now this is going to, let me scroll a bit. This condition is going to check that the current cell is not already visited. And if it is visited or if it is out of the particular grid, we are not going to process this particular data and just say continue. And if the loop is not skipped, we will visit this cell again, visited dot add I comma j. So this particular cell is now also the part of our visited data. And also we need to push it in our heap. So heap push, we are going to push this data in the heap. For that we are going to say heap push min heap comma, what is the value we are going to give? Grid I comma j, this is the actual value in the cell, and what are the indexes I comma j. And now we will only go out of this while loop when for the current query we don't have any more cells to process. And in this case we are going to update this particular result variable, and we are going to say result of this particular query will have the current answer. All right. And when we come out of this whole for loop, we are going to get all the answers for all the queries, and in return we need to give the answer. So for that we need to return a list, and in the list for query in queries we are going to fetch our answers from the result variable. For that we will say result of query, and that's the complete code for this particular solution. And before we submit this code, I have forgot to add one thing, and that is in the line number 8 I have to say visited.add, and I will have to add this as a tuple and not as a values. So add this particular indexes as a tuple, and also here as well we need to add this I comma j as a tuple. So this will be a tuple, and also I need to make sure that this particular I minus 1 is not ending here, it should end here, right? So this is the complete code. There were some few typos, you can ignore it and correct it, and then you will have to submit your code. And once you submit your code, you will notice that all your test cases are now passed, and this is a very efficient solution. So that's the complete code, right? So this is the first part of our code, and then we are running a loop, find the answers for each queries, and then we are returning the answer. So that's it for this particular problem, and that's it for this video as well. So if you have found this particular approach helpful and this particular video helpful, then make sure that you hit that like button And also, if you have not subscribed to my channel as of now, then make sure you subscribe to the channel as well. And I will see you guys in the next video. Thank you for watching, guys.